Hello, everybody. My name is Dr. Surush Azizi, and today I want to talk about estimating expected returns using capital asset pricing model and Froment-French three-factor model. So the goal that we have in this project is to empirically estimate the expected rate of set of assets, let's say five different assets, five different stocks, and one portfolio. So they don't have to be exactly stocks. It can be a portfolio of stocks or even other assets using two prominent asset pricing models that we have in finance. Number one, capital asset pricing model or CAPM, and number two, Farman French three-factor model. Let's get started with capital asset pricing model or CAPM. So essentially, we want to estimate this equation that we have right here. Uh, we want to see the relationship between excess return for asset I and excess return for the market. What does excess return mean? Excess return means RI or return per asset I minus risk-free rates. And excess return for the market just simply means RM or return of the market minus risk-free rates. And so if we estimate this relationship between excess return of asset I and excess return of market, we can get hold of this beta I, and from getting hold of beta I, we can continue to CAPM model. The CAPM model equation is, as you know, is super famous. Expected return of asset I equals risk-free rate plus beta of that asset I times market premium. Now, here we do need to get hold of this beta I, and that's the very first thing that we want to do. Get hold of beta I. How? By estimating this equation that we have. In order to estimate this equation, essentially I have to have data on RI, RF, and to be able to calculate RI minus RF. And I also need RM minus RF or market premium. EI is just zero mean noise that it wouldn't appear in CAPM, as CAPM is a forward-looking formula. Now, how can we get hold of risk-free rate and market premium? There are multiple ways that you can do this, but one of the easiest and maybe the best way to just get hold of the risk-free rate and market premium is by using Farman French data library. So all we have to do is to go to Google page and then just search something like this: pharma, pharma and French data set. And usually number one or maybe number two thing that's a website that you get is this website. The website is mba.tuck.dartmouth.edu, and inside this data set, if you scroll down under this table, you can see that something like under US research returns data, downloadable files. This is given pharma slash French three factors. And then underneath that, we have weekly and daily data. To be honest, we don't need weekly and daily data for this project. So all we need is the first row, pharma French three factors. Now we have different formats. We're going to download the CSV format. So I click on that CSV format, and then when you do that, you'll get the zipped file that I can just unzip this file. If I unzip this file, I get the CSV file. Now, how can we open a CSV file? If on Mac you double click on a CSV file, then this happens. Mac opens that in Mac data, which is not useful for us. So on PC, you can easily just double click on this, but on Mac, you have to hold down the control button and click. That essentially means right click and then open that with Microsoft Excel. So this is the website data set that I just downloaded from the website. So this data set includes everything like 1 month T-bill rates and different things, market rates minus risk-free rate, SMB, HML, that we are going to talk about them later on, and risk-free rates. From year 1926, July 1926, all the way to right now. So if essentially we scroll down, we can get hold of this data. And at the very end, the annual data is also given to us. But uh, before getting to annual data, we have monthly data. Now, I'm gonna get hold of the part of this data set that I actually need. So in the past, we did another project for 5 different companies, and we used data from years January 2015 all the way to December 2024. So I'm going to just focus on 2015-01, and I just go all the way down to 2024-12, and I copy everything here. And as we know, we have done a project in the past here for 5 different companies: Apple, Tesla, Google, Walmart, Coca-Cola. Essentially, here we downloaded the prices using Excel, uh, and we calculated using stock history. We downloaded all this data for these 5 different companies, and we calculated their growth rate and a few other things like a portfolio with highest Sharpe ratio and different things. Now, I'm going to open a new tab, and here on this new tab, I maybe call this new tab, uh, maybe I would call it project CAPM. I just call it CAPM FF3. Yes. I go to cell A3. I'm going to leave first 2 rows blank, and on cell A3, I paste the data that I downloaded from this Farm and French data set. So if I go back to this Farm and French data set, uh, I can go all the way up. And if I do that, I can copy these names and then paste it right here. So I'm going to call the first column maybe time. And then, so the first column is market rate, RM minus RF. And then we have SMB, HML, and RF. And I would call this data set Pharma French data. Now, I got all the data from Farm and French. Now, I need these stocks and the growth rates that I had for them. So let me just copy everything here for these 5 stocks all the way. So I calculated that uh, from January to end of December 20. Uh, So I have to here, first of all, just paste special and paste values. Yes. I don't want to just paste regularly. And the first row right here was empty or blank. Why was it blank? Because I calculated the growth rates here as uh, the price in the following month minus price in the first month divided by initial price. But for the first row, there is no month before that, so I couldn't calculate the return rate for the first month or January 2015. Now, I would call this data maybe return rates. And I want to make sure that the month are the same. So the first month is January 2015. I'm going to check the last month as well. Last month is December 2014. So we are all good. And as you can see, I left one column blank between these two. The reason that I leave one column blank is that I don't want my tables to mix up. Now, something that happens here is that here I don't have the first row. My first row starts row 4. Here for the Fama French, I do have, and I don't need this one to be honest. So I'm going to just delete this so later on I don't mix anything up because I don't need that one. Okay, now that we got that one, I got the growth rate for all different five stocks. Now, how about portfolio? Yes. Uh, we calculated the point with highest Sharpe ratio portfolio in the past. So in order to, here I can go back to this project and take a look at what we had over here. So there was this table of all the weights that I found these points with highest max Sharpe ratio. I can copy all of these weights that I have. So these are weights of Apple, Tesla, Google, Walmart, Coca-Cola at the in a way that they achieve maximum Sharpe ratio. And I come back to my project and I can just paste these horizontally. I don't want to paste them vertically. I don't want to interrupt the flow of the table. So here I'm going to create one more column. I would call this portfolio. Portfolio. So this is a portfolio that I want to construct. I want to calculate its growth based on max Sharpe ratio. If you don't have this, to be honest, you can use another portfolio. Here we just want to practice the CAPM and FF3. So if you don't have this weights that they maximize the Sharpe ratio, you can just use zero point 0.2, zero point 0.2, zero point 0.2, 0.2, 0.2, and they all the weights they add up to 1 because we have 5 of them. But since we already calculated these weights for portfolio with maximum Sharpe ratio, I'm going to use the weights. Now, how can we exactly calculate this return rates for my portfolio? So the return rate for the portfolio is weighted average of return rates for these different stocks that I have. Where so essentially it means the return here, I would say weight of asset one times return rate for asset one plus rate of asset 2, which is Tesla, times like weight of this times weight of each asset times rate of each asset. So weight of Tesla times rate of Tesla plus rate of Google times weight of Google times rates for growth rate of the Google. Then the same thing for Walmart's, weight for Walmart times rate for Walmart plus rate for Coca-Cola times weight for Coca-Cola. Now I got everything and I can hit enter. And I can see that, for example, my the growth rate of portfolio in second month, February 2015, was 3.0149%. However, if I scroll this down, it's not gonna work. The reason is that I didn't fix these numbers on the first row in the formula. So what I'm gonna do is this. I'm gonna put a dollar sign before weights. So I'm going to say dollar sign M, dollar sign 1, dollar sign N, dollar sign 1, dollar sign O, dollar sign 1, dollar sign P, dollar sign 1, dollar sign Q, dollar sign 1. And if I've done everything correctly, when I double click here, yes, it should calculate the return for my portfolio. Uh, and yes, I can see that and everything looks good. Great. Now, so what's the objective again? The objective is to get hold of this RI minus RF. So I have RI or return for these six assets, but I don't have RI minus RF or excess return. So since I don't have it, I have to construct it. So here I'm gonna make another table, maybe call this table so excess return. And for this table, so I don't need to be honest to just copy and paste date every time, but all I need is these names. So these six names, I'm gonna just copy them and I'm gonna leave one column blank, like column maybe N blank, and then paste them right here. However, and then I would call these excess return, like AAPL excess return, TSLA Google excess return, Walmart excess return, and Coca-Cola excess return, and then portfolio excess return. So here we got portfolio return. Here we want to calculate portfolio excess return. How can I calculate these excess returns? So essentially the formula for excess return is the value the return for the asset minus risk-free rate. So risk-free rate here is given in column E. So I can just say this, and if I hit enter, it works. However, I can't scroll this to right. It messes up my column on risk-free rates. You see, this is for Google. I got a strange number. So I'm going to do this. I'm going to, here for column E4, so I don't want the row to be fixed. However, I want the column to be fixed. So when I drag to right, I don't want that to change. So I'm going to fix the column name. I'm going to say H4 minus dollar sign E4. And then I can just calculate this for every single stock. And also I want to calculate this for the portfolio. And then here I can drag this down. And here for Tesla, calculate that for Google, Microsoft, Walmart, Coca-Cola, and portfolio. Perfect. Now I calculated all the excess returns and I have all the excess returns. I have all the, uh, so in the table here from our French table, I got all the market return minus risk-free rate. Everything looks good. I am ready to go to the next stage, which is this one. Create security characteristic line chart. What is that one? Security characteristic line. So security characteristic line has Ri minus Rf on the vertical axis and Rm minus Rf on the horizontal axis. So here I can easily do this. For example, if I want to do that for Apple, I would just select this markets rate minus RF. Again, make sure that you have deleted the data for January 2015 for Farm and French, and therefore the number of rows in this column B and column O for Apple excess return, they exactly match each other. Otherwise, you're going to get an error. You're going to get a chart with two different colors, which is not something that we want. Now that we have this, so okay, how can we make these scatter plots? So first I select the all the x's that I want, market return minus RF, and then I'm gonna select the second one. So here I'm holding the command button down on Mac. On PC, you gotta hold the control button down. And at the same time, select the second column that you want to be selected. So as you can see, these two columns are highlighted. This means both of them are selected and we are all good. Amazing. Now, what I wanted to do is I want to go to inserts and I want to click on this scatter plot and select the first one. Perfect. If I do that, I will get, oops. If I do this, and I'm gonna move these charts to the end of this. I don't want it to be on my data points. So I would just call this chart, first of all, I'm going to give it a proper line. So security characteristic line for Apple. Yes, that's a proper name. Now, essentially here on the vertical axis, we have Ri minus Rf, and on the horizontal axis, I have, so on the horizontal axis, we have market risk premium or Rm minus Rf, which is essentially market risk premium. And then on the, so it's a little bit too small, maybe hard to just see, but we have this name. And on the vertical axis, we have Ri minus Rf, I being Apple. Yes. Okay, so let's just give it a name. To be honest, the names don't matter that much here. We don't need to give them name. I'm gonna just do this for only for this graph. So Ri minus Rf. So X is the term for the asset that we have. Now, the important thing is this, to add the trend line to this graph. So how can we do this? If I just simply I right click here, it's not gonna give me the option to add trend line. How can we do that? First, click on a few points, and as a few points are selected, then you can just right click, and Let me do that one more time. Right click and say add trend line. As soon as you do this add trend line, a small window pops up on the right side, and we want to check these two boxes: display equation on chart, display R squared on chart. So if we take a look at this, it's given me the equation for this line: y equals 1.18 x plus 0.7927. So essentially that 1.18 is the beta that I was looking for. Alpha is positive for this, so it means Apple has outperformed the predictions of CAPM model by 0.79% per month. So around 0.8% per month. Apple has outperformed CAPM. Good for Apple. Now, I got the beta for this one. Now all I want to do is to just do the same thing for all other stocks. So uh, let's just quickly do this. Every single time I'm gonna select this guy and market risk preview, and then Tesla, go to insert and then chart. Let's see if we have done everything correctly. I don't think so. Somehow my this column B is not selected, is not highlighted. So I know that I've done something incorrectly. I'm going to just delete this and then click on one cell here on the table. And then I'm going to just try it again one more time. So here I'm going to select all the data, hold down the command button, and at the same time select Tesla. Now we're good. And now that I did that, I can just go to inserts and scatter plots. Yes. So this is the scatter plot for Tesla. So I can just change the title, security characteristic line for Tesla. And from here, I can click on these points and then just add trend line and display equation on chart, display R squared on chart. And then great. So I did it for Tesla, I did it for Apple. I'm gonna do the rest of them, oops, a little bit quicker. So here, I'm gonna select this again. Command bottom down, select data for Google, insert, scatter plot, and move this maybe down here. So SCL for Google. Add trend line, display equation on chart, display R squared. Great. I got it for Google. Next company would be here, Walmart. Go to insert, scatter plots, SCL for Walmart. So this is my next curve. And okay, let me zoom in. I want the trend line and I want beta and R squared. So essentially, R squared means that for this example, only 15% of variations in Walmart excess return can be explained by market excess return. That's the just concept of R squared means that. Uh, so one more time, I'm gonna select all the market risk premium, and then I go to this table and select data, hold the command button down, select growth rate for Coca-Cola. So here we are doing this SCL curve for Coca-Cola. So insert and then scatter plots. And let me move this maybe. Okay. So here I got SCL for Coca-Cola, for KO, and then I just add the trend line and display equation and R squared on the chart. So here we can see that 23.75% of variation in Coca-Cola, Coca-Cola's excess return has can be defined by variation in market excess return. Perfect. One last time, I'm gonna do the same thing. Choose the market return. And at the same time, I'm gonna choose the portfolios, excess return. So now that I got that, I selected that, I go to inserts and then charts. And I'm gonna put this chart right over there. So this is excess return for portfolio. So SCL for portfolio. Great. And if I want to get hold of the trend line, add trend line. So I click on one of these points, add trend line, display equation on chart, display R squared on chart. Great. Now I can see that my portfolio's beta is 0.94. So remember the definition of beta. Essentially, beta means sensitivity of uh, excess return for asset I to changes in excess return for the market. How sensitive is this excess return for asset I to changes in uh, whole market excess return? So I calculated all of that, and next I can do something. I can just double check my betas using a predefined function in Excel like line st. Uh, let's see how we can do that. So here I go back to my data. Let me close this. So I got 6 different charts and everything looks good here. So let me go here and then I can say, now I want to get hold of same things. Maybe not, it doesn't give us like R squared, but the alpha and beta. So another way that we can do this is to use line ST. How can we do this? So here I'm gonna say equals line ST. So equals, so first of all, let me write the title. The title is this. Uh, the title, what I want to do is this. I want to calculate or estimate, let's say estimate beta for, and let me just paste these names. Let me just copy that one more time. Copy these 5 and 6 names one more time. Copy, and then let's go back here. Paste special, transpose. So estimate beta for these. So how do we do this? I can just say equals line st, and then after that I can say just so the format that we have is this. First you gotta choose your y's, and then you gotta choose your x's. Now the y for me here is the vertical axis, so the y, for example, is this guy. So I'm gonna select this, put a comma, and then my x would be this. Okay, so I got beta, and this is also alpha. So this is alpha, this is beta. Let's just see that if our beta and alpha matches the one that we got here. So I got beta 1.1799, which is essentially 1.18. Perfect. And alpha was 0.7927, and here 0.7927. So I got exactly same alpha and beta. That's great. I can just keep doing this 6 times, or a little bit maybe easier is to just copy this formula and then paste it, and then here change letter O to P, which is my next variable, and then to Q for next variable, OPQR, and then S, and then T. Okay. Let's make sure that everything, for example, I'm going to check maybe Coca-Cola as well. Here I got point 4856, 4856. For portfolio, I got point 9427. Let me see what I got for portfolio 9427. Perfect. They match exactly. Now I got all of my betas. Perfect. Now, at the end of this project, so I want to have something like this. Let me copy all of these and maybe I can go here and on a new tab and I can just paste all of these as values. Paste special values. Let me zoom in. So here is we have the assets and here we got beta. Now, next thing that now I got beta for all of these assets. Now I want to do expected rate of return, E of R, for these stocks based on CAPM, ER, based on using CAPM. Now, let's see how, if we have beta, how can we do this? So I got the beta. Also, there's another way, the third way that we can do like slopes, Y and X. That's also possible. But essentially, this is my CAPM equation. CAPM is a forward-looking equation. It talks about expected rate of return for the future. I got all the beta i's. How about ERM minus RF? What should we do? Should we use the average of ERM minus RF in the past 10 years? That the data that we got for the past 10 years, only maybe. So these are ERM minus ERF. Should I just calculate the average of that, which is like the monthly average is 1.01? Which means like the annual average is something around maybe 12%, 13%. Not exactly. Maybe we had really good market in the past 10 years. We have to focus on the long-term average that we had for this. So remember this Farm French data set that we downloaded initially. If we scroll all the way down, we have annual data, and I can see that in based on annual data, if I go, so we started collecting data in a modern way since 1963. If I take an average of the whole data, uh, market premium for the whole from 1963 and afterwards, I can see that the average is 7.76, or just if I round it, 7.8. That's the market average for my market premium. That's the average for market premium that I got. So rather than in this equation of CAPM, I can just replace this ERM minus RF by just 7.8. How about risk-free rate? Risk-free rate, since CAPM is a forward-looking model, I should take a look at the current risk-free rate that can be found on uh, the Federal Reserve. So it was uh, until yesterday it was 4.11. Now it's 4.17. Now let's just so when you want to do that, when you want to use CAPM, you're gonna just use this rate that we have, I'm going to just use 4.1 since I already have used it in the project description 4.1. However, so essentially, if I replace RF with this 4.1 and then this beta I, so this is what I'm getting. This is the equation that I'm getting, yes. Uh, 4.1 plus beta uh, times 7.8. So let me just use that right here in my, let's say, here, let's call this final delivery or final table. Yes, final table tab. So here I want to just report everything. So ER reported based on CAPM would be equals 4.1 plus beta times 7.8. Boom. And I can drag this down and I can calculate that for all of these. So what's the interpretation of this? So let me just interpret first one more time beta and then cap m. Interpretation for beta essentially is this. For Apple, for example, we saw that it's 1.18, yes? Uh, Essentially, it means if market excess rate goes up 1%, the Apple's excess return goes up 1.18%. For Coca-Cola, if market excess return goes up 1%, Coca-Cola's excess return would go up 0.48%, almost half a percent. Excess return, expected return based on CAPM essentially means for the future, I expect that Apple to have to bring 13.3% return. Yes. So it's a forward-looking formula and model. For the future, I'm expecting Apple to bring 13.3% return, Tesla to bring 18.5%, Google 11.4, Walmart 7.6, Coca-Cola 7.9, and the whole portfolio based on weights that they come from maximizing Sharpe ratio, I expect that to give me 11.45% return. Would it give me for sure like 13.3%? No, it's not going to give me exactly that number. It might give me like higher than that or lower than that. We don't know what's going to happen in the future. However, this is something that I expect. Perfect. With that being said, I'm done with the CAPM model. Now I can move on to the next part, which is Fama French model. So how can we do Fama French model? Let's go to tab data. Under tab data, make sure that you have data analysis. If you don't have data analysis, on Mac you can go to analysis tools and check the box for analysis tool pack and then click on OK and then you get hold of this data analysis. On PC, that would be a little bit different. You're gonna go to File and then Options and then Add-ins and then select Analysis Tool Pack and click on Go. Don't click on OK, click on Go. But essentially, you can get hold of this data analysis. Before doing regression that we need to do for Farman French three-factor model, let me say this. Let's copy these column names and paste them right here because when you're doing regression, there should be no distance. We're not going to be using the second table. We're going to be using the third table. So for regression, there should be no gap between labels or column headers and the actual data. So that's why we do this. Okay, after doing so, all I have to do is to go to data analysis and then I choose regression. And let me just delete everything I have here because I want to start from blank. So this is going to be the page that you can see on regression. Yes. Now, what do we have here? On the top, it said regression. Then I have input, input Y range, input X range. And then I have here labels and new worksheets. So what is this Farman French three-factor model? Here, we know that from the theory part, Farman French three-factor model is given. The model is something like this. So essentially, I want to regress this like excess return that we have on three factors. Number one, market premium. Number two, uh, SMB, small minus big, and then HML, high minus low. Farman French claimed that, hey, variation in the market risk premium is not the only source of return for asset I, but also there are some persistent returns that they are coming from size of the company, and they said that the smaller size companies on average in the long run they tend to do better than bigger size companies. And then for HML we have this that on average, companies with higher book to market value, they tend to, in the long run, they tend to do better, have a better performance than companies with low book to market ratio. So these numbers, they all come from Farman French data set. These markets minus RF is the first one, SMB and HML. So I have all of them. All I gotta do is this. So input Y range, I'm gonna click right there. And then for my Y range, I'm gonna select AAPL underscore ER, including the header. I'm gonna include the header. And I'm gonna select everything until the last row. Perfect. Then I'll go here, I click here, and then I do input X range. So X range would be here, these three columns, including again the header, and all the way down. Here I got the header. Since I have chosen the headers as well, I'm going to click on here on labels. And here, regression, when I do this regression, the result is going to pop up in a new window. So I want to name that new window, maybe call it AAPL underscore FF3, Comma French three-factor model. And as soon as I click OK, it's going to give me this result. So here, essentially, we have this intercept and this beta for market minus RF and then SMB and HML. So these are the numbers that we got for the first stock that we have. So here I can just select all three of these and go here to my final thought, and I can just say here on the final thought we have three different things. Let's just let me just copy them from here. So all the names, I'm gonna just copy these names here. Just paste them right here. Great. So now I got for Apple, I got all of these results from the regression. Let me just copy them. And then I'll go here and paste them in the final table. I'm going to paste them transpose, so horizontally. Now, first, I'm gonna just calculate the same thing. Uh, I'm not gonna be using this alpha, to be honest. Here, when we wanna make futuristic predictions, we are not gonna be using alpha. However, this alpha, it just means, let's say, alpha that had in this model. It means, for example, Apple on average, every single month, Apple was outperforming the prediction of CAPM by 0.79. So here, again, CAPM makes prediction about expected rates of return for future, yes. But for the past 10 years, Apple was outperforming CAPM predictions by 0.79% every single month. Tesla was outperforming CAPM prediction by 2.3%. And then Google was outperforming that by 0.799, essentially 0.8%. Walmart was outperforming CAPM prediction by 5.2, and then Coca-Cola was underperforming, since alpha is negative, was underperforming the CAPM prediction by a factor of 0.179%. And my whole portfolio was outperforming the CAPM prediction by 0.896%. Here, my model, Apple is outperforming this Palm and French three-factor model by 0.6459% a month. Great. So I did that for Apple. All I gotta do is to go back here to my data and then do five more regressions. I can do that really fast. Just go to regression, and all you gotta do, don't change the X range. X would be the same three variables. So just change these two. First, I'm going to change O to P, and then here O to P. And then here change AAPL to TSLA. Then I click on OK, and boom, I got my result for uh, Tesla. And I'm going to copy these three variables here for my final table, and I'm going to paste them transpose horizontally. So I got three factors. So we have like for cap and we have only one beta. For FF3, we have three betas. One beta is almost the same beta for market risk premium, but two other betas is beta or coefficients for sensitivity to this SMB, small minus big, and beta for HML. Yes, high book to value market minus low book to market value. And then I'm going to do that for Google. So Q, this is going to be Q as well. And then this is going to be Google. And boom, I got these three. So I'm just gonna select this. Again, Google is outperforming Palm and French three-factor model. I go here. I can just paste these, uh, paste special transpose. That was for Google. Let me do after that So regression, we did Q, OPQR, and then here I got Walmart, WMT, and these are the data for Walmart. Copy these three, come here, paste it, transpose. So I got this, and then Coca-Cola. Let's go back here. Let's run the regression one more time. Data analysis, regression, R, then S. So this is Coca-Cola. I'm going to call this KO, FF3, and these are the results. I can see that again, Coca-Cola is underperforming from a French three-factor model, and I get all of those numbers. And one more time, I'm gonna do this for the whole portfolio. So I'll go here and I click on data analysis regression, and S, I'm going to change that to T. And here I'm going to change that S to T. And here it's portfolio. And click on OK. And I'm going to copy all of these for portfolio. I got these numbers. Okay, I got all these betas that I had in my Farm and French three-factor model. That's great. Now let's see how we can actually, so the final result of this CAPM and Farm and French three-factor model, so CAPM and FF3, the final result must be just a number. Now, here in the past, we just saw that RF is 4.1. To be honest, from just today, uh, November 7th, 2025, as of today is 4.17. I'm going to be just using 4.1 because I've done all of my calculation and it's based on this. But Uh, ERM minus RF based on historical data, long-term average from 1963 to 2024. This is 7.8%. Then expected return for small minus big is 2.2. And the last one, expected return for high minus low, is expect is 3.7. So this is the formula that I'm going to be using. So the numbers, remember, 4.1, 7.8, 2.2, 3.7. Let's have this in mind and let's construct it. So Palm French three-factor model FF3 expected return equals 4.1 plus. Then after this, we are going to say beta, first beta, market beta times 7.8 plus the beta for SMB, the coefficient for SMB times 2.2, average historical number that we got, plus coefficient for HML times 3.7. Yes. And I hit enter and I get this. So these are the exact numbers that I used. Yes. So What does it mean? It means that based on Farman French three-factor model, we expect that Apple to have uh, expected return in the future to have expected return of 11.3. Like we expect Apple to have a return of 11.3% per year. Would it be 11.3% in, like, let's say next year, let's say 2026? We don't know. Maybe it brings us a negative return even, or maybe way more than 11%. This is what Palm French three-factor model predicts, but the ex it tells us that the expected return for Apple would be this much. And if you want to calculate that for all other stocks, just bring this down, and you can see that the expected return for Tesla is 15.3, for Google 9.98, and around 10% for Google. For Walmart, 6.7%. For Coca-Cola is 8.28%. And for the whole portfolio is 9.847%. So here we started with almost a blank page, not entirely blank page. All we had was the growth rates, the return rates for these five different stocks from uh, and then we imported the Pharma French data set, and we calculated the excess return, we calculated the beta for CAPM. Based on that, we calculated expected return for five stocks and one portfolio. And then we estimated Pharma French three-factor model. We ran six different regressions. We got hold of all the beta coefficients, and based on that, we did predictions. We estimated the expected rate of return based on FF3 for these five stocks and one portfolio. I hope you enjoyed this empirical example that we have, and have a wonderful time.